I'm Dr. K. Sharda, working assistant professor of mathematics in Government City College. Today I'm going to explain you about the bisection method. So bisection method is one of the root finding method. So now I'll explain in detail about bisection method. So the root finding problem. Before going to the bisection method, let us discuss some points which are required for bisection method. We now consider one of the most basic problems of numerical approximation, namely the root finding problem. This process involves finding a root or solution of an equation of the form f of x is equal to 0 for a given function f. A root of this equation is also called 0 of the function f. So 0 of the function f of x means the solution of the f of x is equal to 0 is called 0 or a root of that equation. The problem of finding an approximation to the root of an equation can be traced back at least to 1700 BC. A cuneiform table in the Yale Babylonian collection dating from that period gives us a base 60 number equivalent to 1.414222 is an approximation to root 2, a result that accurate within 10 power minus 5. This is brief history about bisection method. So the bisection method idea, it came from intermediate value theorem. So we first consider the bisection method, which is also called binary search method, which is based on the intermediate value theorem. IVT means intermediate value theorem. Suppose a function f is a continuous defined on the closed interval AB is given with f of a and f of b is opposite signs. Then by intermediate value theorem, there exists a point P belongs to AB for which f of P is equal to 0. So in what follows, it will be assumed that the root in this interval is unique. So we are to find the root of the bisection method, we use the concept of intermediate value theorem. What is intermediate value theorem? Suppose you have two values AB which have the opposite signs, then there exists a value P belongs to in that interval A comma B such that f of P is equal to 0. That P is the root of the approximate root of the equation. So that is the concept of intermediate value theorem. We use this concept for finding the root in the bisection method. See here, I have taken two values. See A, f of A, you see in the graph. F of this is f of A. Wait a minute. So f of A is less than 0 and you see f of B is greater than 0. There is a value P in which f of P is equal to 0. See, it is on the x-axis. There is a value P. So f of P is equal to 0. So here A and B are with two values with opposite signs. There exists a value P such that f of P is equal to 0. This is concept of intermediate value theorem. We are using this concept for bisection method. The bisection method in mathematics is a root finding method which repeatedly bisects an interval and then selects a subinterval in which a root must lie for further processing. So this is about bisection method. It is a root finding method which repeatedly bisects an interval and then selects a subinterval in which root must lie for further processing. I'll explain in detail. So first one is in the bisection method. What is the step one is choose 2 points A and B such that f of A into f of B is less than 0. That means f of A and f of B has opposite signs. Must have opposite signs. That is the first rule. So you have to choose always two values A and B such that f of A is less than 0, then f of B should be greater than 0. Or if f of A is greater than 0, then f of should be less than 0. They must have opposites. Then only f of A into f of B must be less than 0. So this is number one. Next one is choose the first initial approximation. X naught is a plus b by 2. So first you have to choose two values with different f of a and f of b must have different signs. Then choose x naught is a plus b by 2. Then the next step is evaluate f of x naught. Evaluate f of x naught. Next, decision making for replacing a and b with a new value x naught. So how will you replace a, b with a new value? So first what we have to do, find f of x naught. See, what are the values you will get? It may be 0, it may be less than 0, it may be greater than 0. So if you find out f of x naught, how will you find x naught? That is a plus b by 2. What is a and b? They are the two values where f of a and f of b has different signs. So after finding x naught, what you have to do is, you have to find out f of x naught. After finding f of x naught, check whether it is 0 or greater than 0 or less than 0. If it is 0, then x naught is your required result. It is a required root. Suppose if f of x naught is greater than 0 or less than 0, then how will you proceed further? We'll see in the next slide. See, if f of x naught is 0, then x naught is the required root of your given equation f of x is equal to 0. Suppose if x naught is, see here, f of x naught is greater than 0. F of x naught is greater than 0. See, three cases I told you. If it is 0, then that is the root. If f of x naught is greater than 0, then see. If f of a is also greater than 0, f of x naught is greater than 0, f of a is also greater than 0. The root should be always lies between one greater than 0 and one less than 0. Suppose f of a greater than 0, f of b a is greater than 0, then definitely f of b should be less than 0. Then the root lies between x naught and b. So then next x1 is x naught plus b by 2. Be careful. If f of a is greater than 0, already f of x naught is greater than 0. The root is always lies between less than 0 and greater than 0. So f of a greater than 0 means what? F of b less than 0. So the root should be always lies between less than 0 and greater than 0. So it lies between b and x naught. So your x1 value is x naught plus b by 2. Suppose f of b is greater than 0. That means what? F of a is less than 0. This greater than 0 means it is less than 0. The root should be lies between a and x naught. See, root lies between a and x naught. Then what should be your x1? A plus x naught by 2. So, depend upon your f of x naught value, you have to replace with ab. Okay. So, if f of x naught is greater than 0, then what is your x1? X naught plus b by 2. Suppose if f of x naught, f of a greater than 0, this is the case. If f of b is greater than 0, then your x1 is a plus x naught by 2. If f of a is greater than 0, your x1 is x naught plus b by 2. Suppose f of x naught is not greater than 0, it is less than 0. Then what happen, we'll see. Suppose if f of x naught is less than 0, then x naught replaces any one of ab like this. Suppose if f of x naught is less than 0. Suppose f of a is also less than 0. Then immediately what will happen? F of b is greater than 0. So this is less than 0, this is greater than 0. So root lies between x naught and b. So your x1 is x naught plus b by 2. Suppose f of x naught is less than 0, f of b is also less than 0. Immediately what will happen? F of a greater than 0. Then root lies between a and x naught. So your x1 become a plus x naught by 2. So like this, so you depend upon your problem. If it is greater than 0, apply this previous slide. Okay. If it is less than 0, let's take like this. So, and the root should be always lies between one less than 0, one greater than 0 value. That you should remember. Okay. Next. Repeating the step 2 for x1 in place of x naught till the desired accuracy is obtained. So, in the previous step, in the second step, you applied x1. You got x1. Next, what you have to do? You have to find out f of x1. So already you know, suppose f of a is less than 0, f of b is greater than 0. For example, let f of a less than 0, f of b greater than 0. You find out f of x1. Suppose f of x1 is also less than 0, then the root lies between x1 and b, less than 0 and greater than 0. Then your x2 will become x1 plus b by 2. For example, if f of x1 is greater than 0, what is less than 0 value of this one? So your root lies between x2 is equal to a plus x1 by 2. So like this, you have to go on, continue the procedure. Okay. So next one is replace x naught with the x1 till the desired accuracy is obtained. So next one, what you have to do? Next, you got x2 now. Next, find f of x2. If f of x2 is greater than 0, then choose a value, sub value, either it is x1 or a, whatever it may be, nearest to this, which is less than 0. Take that value, and let x3 is equal to, suppose if f of x1 is less than 0. So this is greater than 0, this is less than 0. So your x3 will be x1 plus x2 by 2. Suppose f of x2 is less than 0. For example, if f of x1 is greater than 0, then your x3 is x1 plus x2 by 2. Like that, what you have to do, you go on repeating the procedure till the accuracy is obtained. And number one is, you have to choose two values with opposite signs. Number two is bisect it, and after that find again the value and choose two values again with less than 0, greater than 0 sign, and again bisect it. Like that, you go on bisect the subintervals till the desired accuracy is obtained. So this is one example I'm doing here. I think you followed the bisection method. So what is bisection method? What is the first one? Choose two values a, b in such a way that f of a is less than 0 and f of b is greater than 0. This is step 1. Step 2 is x naught is equal to a plus b by 2. Step 3 is, first you have to find out f of x naught. If f of x naught is less than 0, then root lies between 1 greater than 1 less than. So x naught plus b by 2. Suppose if f of x naught is greater than 0, then root lies between a and x naught. So a plus x naught by 2. This is the procedure to choose x1. After choosing x1, what you have to do? You have to find out f of x1. If f of x1 is, suppose if f of x1 is greater than 0, then what is the less than value used to see? For example, if f of x naught is less than 0, then your x2 will become x1 plus x naught by 2. Suppose if f of x2 is less than 0, suppose f of x naught is greater than 0, then your x2 will become x1 plus x naught by 2. Like that, you choose always one greater than 0 and less than 0. Be immediate before this value you have to choose, not with the starting values. Okay, like go on bisecting the interval, you will get the desired accuracy. So this is about bisection method. Now I will explain this bisection method with taking some example. So find a real root of the equation x cube minus x minus 11 is equal to 0. So I have chosen f of 2. F of 2 is 8 minus 2 minus 13, 8, so minus 5. F of 3 is 13. So I have chosen 2 points with two different signs. What is the 2 points here? A is equal to 2 and b is equal to 3. So what is x naught? A plus b by 2. That is 2.5. So like the procedure, like the algorithm, I am go on explaining you. So first you have to choose two values with two different signs and take bisect of this 2.5. Next, find f of 2.5. So f of x naught there. Next, x 2.5. Next, okay. Now find out f of 2.5. Okay. 2.5 here, I missed one value. F of 2.5, that is 2.5 whole cube minus 2.5 minus 11. If you find out this value, f of 2.5 value, 1 minute we'll do, I'll do with the calculator. Use the calculator and find the value of f of 2.5. I'm doing that. 1 minute. So 2.5 whole cube, 2.5 into 2.5, 2.5 into 2.5 into 2.5, that is equal to 15.625 minus 13.5. So how much you will get? 2.125. So this is 2.125, that is greater than 0. So here f of 2.5 is greater than 0. So what should be your x1? Tell me now. What will should be, it should be always lies between greater than 0 and less than 0. What is less than 0 value? 2. What is greater than 0 value? 2.5 by 2. So 2 plus 2.5 by 2, that is 4.5 by 2. So 4.5 by 2 value is this. You will get this value. Okay. 2.125. 2.25. So decision making for replacing 2 and 3 with a new value of x naught is equal to 2.5. 1 minute. So 2.5 value is greater than 0. So 1 minute. 4.5 by 2. So 4.5 divided by 2 is equal to 2.25. So this is equal to 2.25. So next one is 2.25. So you got next value is your x naught is now 2.25. Find out f of 2.25. Take it as this is x1, new value. So what is f of 2.25? That is f 2.25 whole cube, 2.25 whole cube into 2.25 into 2.25. What is your equation? 2.25, 2.25, 2.25 minus 13.25. That is equal to minus 1 point. So minus 1.859375, that is less than 0. So therefore the root lies between for which one it is getting 2.25 and 2.5. Because for 2.5 you see, for 2.5 you got greater than 0 and 2.125 you get less than 0. So root lies between these two. So therefore x2 is equal to 2.25 plus 2.5 by 2. So what is you will get? 2.25 plus 2.5 divided by 2. That is 2.375. It is already I have explained you 2.25. Previous also we got 2.25. So 2.25. So f of 2.25 value is this. This is already I have explained you. So 2.25 plus 2.5 by 2 is how much? 2.375. So find f of x2. So like that you have, so I have already explained all these steps to you. So first one is you have chosen two values 2 and 3. Bisect it, you got 2.5. Find out f of 2.5, you got positive value. The root always lies between negative and positive value. So 2 plus 2.5 by 2, that is 2.25. Next, find f of 2.25, that is minus of this, less than 0. So root lies between 2.25 plus 2.5, that is 2.375. Next one is, see, same, whatever I have explained, it is there. So f of 2.375 is getting 0.02, means it is positive value, greater than 0. So positive value means again what should be your x3? Your x3 is positive and negative values. So 2.375, where you are getting negative value 2.25. So 2.25 by 2. So find some value and again find out f of x3 and go on repeating this process. You will get like this. See, I have made it a table. See here. A, f of A, B, f of B and f of B by 2. We are up to here. I have already explained you. See here. It is greater than 0. So 2.375. The root lies between one greater than 0 and one positive value. So your root lies between 2.25 and 2.375. You will get 2.315. For that what you are getting? You are getting negative value. So negative value means it is replaced with A. Positive value means it replaced with B. Remember that. Whenever you got negative sign, write it in the place of A. Whenever you get positive sign, write it in the place of B. So you got negative sign. So write this value in the place of A, 2.3125. And B is already positive. So 2.315 plus 2.375. So bisect it. You got 2.34375. You are getting negative value. So negative value means again it replaces with A. So 2.34375. Positive value is same as it is 2.375. So again bisect it, these two. You get 2.359375. You are getting again negative value. So replace with A. So A, it will come to A. Again it is positive. Again bisect it. Don't worry about f of A and f of B. This is not necessary for us. It is not necessary for us. Only you have to be careful with A and B only. One negative, one positive. So 2.3671. Again, still you are getting negative. So again, it will replace with A, 2.361. Again, 2.375, 2.37. Again, still it is minus. So again, 2.37, 2.375, 2.37. Again, negative. So it will replace with A only. Okay. But now you got positive. So therefore, this value comes where? It comes to B. See, that is, remember, if you substitute this value, if you get negative sign, replace this with A. If you get positive value of the function, then replace with B. So now you got positive value. So replace with B, 2.374023. Again bisected, 2.37. Again you got negative. Negative means it should be replaced with A. See, 2.373535. And already this is there for positive. So continue the same. So if you form a table like this, then it is very easy for you to choose which is less than 0, which is greater than 0. So again bisect it. So I did up to 11 iterations. It is enough now. So 2.373779, and you observe you are getting near close to 0. So what is the meaning of the root? By substituting this value, you have to get the answer 0. So compared to all these values, you are nearing to 0 means, so in the sum or 2-3 steps, you will get almost it is 0.0000 like that. That is your required result. So when they ask in the exam, you can't do all the 11 iterations. You maximum you do 4 or 5 or whatever they ask. Suppose they ask 4 iterations, do the 4 iterations. If they ask 5 iterations, do the 5 iterations. Depend upon the examiner, you have to do the problem. Okay. Next, given that f of x is equal to x square minus 2, our task is finding the root of this equation. Okay. So we have to choose two values. One is less than 0 and one is greater than 0. So let us start with. So a naught is equal to 1. F of 1 is minus 1 less than 0. F of 2 greater than 0. So 1 less than 0, 1 greater than 0. See, I made a table here. So we started with, we started with 1, 2. So 1, first this is iterations. 1, 2. A is 1, B is equal to 2. Okay. Then 1 plus 2 by 2. Your x naught is 1 plus 2 by 2. That is 1.5. Immediately what you have to do, you have to find out what is f of 1.5. What is your equation? X square minus 2. That is 1.5 whole square minus 2. Definitely you will get this value is 1.5 into 1.5. How much you will get? 1.5 into 1.5. So 1.5 into 1.5 minus 2. So how much you will get? 0.25. That is greater than 0. So your 1.5 value are getting greater than 0. So keep it as it is with B. And what is less than 0 value? 1. So 1, 1.5. Again bisect it. So your x1 is 1 plus 1.5 by 2. That is how much? 1 plus 1.5 divided by 2. How much you will get? 1.25. Again find out 1.25 whole square. 1.25 into 1.25 minus 2. So minus 0.375. So f of x1 value is minus 0.4375. That is less than 0. So for 1.25 you are getting less than 0. So your 1.25 should be in A. So like that you have to do. 1.25 should replace with A. For where you are getting positive, for 1.5 you got positive. So 1.25 plus 1.5. So next step is 1.25 plus 1.5 by 2. How much you will get? 1.25 plus 1.5 by 2 you get 1.375. Now find out 1.375 into 1.375 minus 2. You will get less than 0 value only. So f of x2 is minus 0.109375. So less than 0 only. So less than 0 means again it replaced with a only. See, 1.375. What is positive value? 1.5. Again 1.375 plus 1.5 by 2. You get again by 2. You will get 1.375 plus 1.5 by 2. How much you will get? 1 minute. 1.375 plus 1.5 divided by 2. You get 1.375 plus 1.5. 1.375 plus 1.5 divided by 2. You will get 1.4375, this value. So what is 1.4375 into 1.4375 minus 2? 0.06, you got positive value. So f of 1.4375 value is positive. Because it is positive, it come to the B place. So be careful. You got positive value. So that's why it is in the B place. And what is immediate negative value? Immediate negative value is x2, that is 1.375. See, it is as it is. Okay, again you should bisect it. You will get 1.40625. 1.40625 is less than 0. That's why the root lies between these two. Again bisect it. You will get this 1.421875. You will get positive value. That way it is in the place of B. Again less than 0, greater than 0. Again bisect it. You will get this value. This is less than 0. That's why it is here. So like that, less than 0, greater than 0, less than 0, greater than 0, replace it. If you get less than 0 value, replace that value with A. If you get f of that value is greater than 0, replace with that value with B. Like that, I did 20 iterations. See, almost your root must be approximately 1.41 like that, 1.4142 like that. So up to 18 previous, you see the difference between the previous one and this one. Then you can know the what is the root. Okay, so this is the method to find the root of the equation. Okay, so here I did some 20 iterations. Okay, next one more problem. Find one root of e power x minus 3x is equal to 0 corrected to 2 decimal places using the method of bisection. F of x is equal to e power x minus 3x. So f of 1.5 is e power 1.5 minus 3 into 1.5, that is minus, that is less than 0. And f of 1.6 is greater than 0. So the root lies between greater than 0 and less than 0. So 1.5, 1.6, bisect it. 1.5 plus 1.6 by 2. 1.5 plus 1.6, 1.5 plus 1.6 divided by 2, that is 1.55. This is nothing but a plus b by 2. Okay, so 1.55. So what is f of 1.5? It is greater than 0. So the root lies between greater than 0 and less than 0. So when it is greater than 0, it should be always come to this place. Okay, greater than 0. And what is less than 0 value? Already we have 1.5. So 1.5 plus 1.55 divided by 2, 1.525. Find f of 1.525 by substituting in this equation e power x minus 3x. You got again positive value. Because it is positive, it will come to here. Okay. 1.5 plus 1.52 by 2, 1.5125. Again it is greater than 0. So it will come in the place of B. Next, bisect it. You got this value. It is less than 0. So this will come to A place. Remember that. So B is already there, positive value. Again bisect it. Again less than 0. So this value comes here. Again bisect it. So let's see, you are getting nearer to 0.000 like that. If you do 2-3 steps, you will get nearly 0.000. So that is 10 to the power of -3 accuracy here. So like that, we can solve the problem by desired accuracy. Whatever accuracy they are asking, up to that iterations you have to do. Okay. The next find x square minus 3 starting with the interval 1 comma 2. See here, clearly I have explained you. A is 1, f of a is negative less than 0. 2, it is greater than 0. So the root lies between less than 0 and greater than 0, 1.5. So 1.5 is, what is f of value is less than 0. Less than 0 means it will always come to the a place. So your 1.5 will come to a plus. See here. Next again, 1.5 to bisection, 1.75. You got greater than 0. So therefore, 1.75 will come to the which place? B place. See. Okay. Again bisect it. We got 1.625. Again less than 0. Less than 0 means it will go to A place. See. Again you bisect it, 1.6875. Again less than 0. So it will go to A place. So again bisect it. You got this. So don't worry about f of a and f of b, not necessary for you. Only we required is a plus b by 2 and your this value. That is the only thing we required. So negative, again less than 0. Therefore it will come to a place. Next bisect it, 1.7344. You positive. Positive means it will come to b place. See. Again bisect it. You got. So this is the, if you go on 2-3 steps, see here answer 0.00. Next, if you do 2-3 steps, you will get 0.000. So some 7-8 steps, 7 we can get the desired result. Okay. Next, bisection method. Apply bisection method and find the value of x cube plus 4x square minus 10. So f of 1 is -5, f of 2 is 14, two different signs. Therefore, the root lies between 1 and 2. Okay, bisect it. What is 1 plus 2 by 2? 1.5. 1.5 is positive value. So the root lies between negative and positive value. So root lies between 1 and 1.5. So root lies between 1 and 1.5. Bisect it, you get 1.25. It is negative sign, so less than 0. So what is greater than 0 value? 1.5. Less than 0 value is 1.25. So it will become 1.25 plus 1 plus 1.5 by 2. That is 1.375. So like that, see, I have substituted and make the value. So this is 1, 2. This is a plus b by 2. This pn is nothing but an plus bn by 2. Okay. So this one is less than 0. Therefore, it is less than 0. Your 1.5 will become f of 1.5. F of 1 plus 2, 1.5. F of Pn. This one. F of Pn is important for us. Valid. So f of Pn is greater than 0. Because it is greater than 0, it will come in the place of Bn. Be remember that. Next you see, don't worry about f of n, remove it. So the bisection of this 1.25. 1.25 is less than 0. So it will come to A place. Be remember. Next one is bisect it, 1.375. You got positive value. Because it's a positive value, it replaces with B. Then bisect these two, you got this value. You got negative. Negative means less than 0. Less than 0 means it will come to A place. Then again, bisect it, 1.3475. You got negative value. Negative value means less than 0. Less than 0 means it will come to A place. Then again bisect it. You got negative value again. Again, negative value means again it will come to A place. Again bisect it. You got positive value. Positive value means it will come to B. Again bisect it. You got again less than 0 value. So it will go to A place. Again bisect it. You got 0.000. That is positive value only. So therefore it will come to B place. Then again bisect it. You got less than 0 value. Less than 0 value means it will go to A place. Again bisect it. You got again less than 0 value. go to a place. Again by 2, again less than 0 value, again it will go to a place. So like that, see here the difference between the previous term and this term. This is the last one, is the difference between these two terms. That is 0.00000. That means almost we are coming to the nearer to the 0. Okay. So the final remarks of bisection method is, the bisection method has a number of significant drawbacks. Firstly, it is very slow to converge in that n may become quite large before p minus pn becomes sufficiently small. The meaning of this is this one. Sufficiently small means the difference between this value and this value is almost very closer. For to get this stage, we need more iterations. That is the meaning of this. Also, it is possible to that a good intermediate approximation may be inadvertently discarded. It will always converge to a solution, however, and for this reason is often used to provide a good initial approximation for a more efficient procedure. So we use bisection method for good initial approximation because it is very slow. We can find the solution, but number of iterations will be more in this problem. It is very simple and robust method, but it is also relatively slow. Because of this, it is often used to obtain rough approximation to a solution, which is then used as a starting point for more rapidly convergent methods. The method is also called the binary search method or the dichotomy method. So this is about bisection method. So what we learn about bisection method is, it is a very slow method. It will converge very slowly, and it will use always this bisection method for good initial approximation to for more efficient procedure. Okay, so this is all about the bisection method. Next tomorrow we'll discuss with some more method for finding the root of the given function f of x is equal to 0. Thank you.